It began with a flicker, just a subtle anomaly in the data. A cold, silent, and fast-moving object was traveling through our solar system in a way nothing ever had before. Telescopes from observatories in Hawaii to South Africa were the first to detect it. Soon after, NASA confirmed its existence, a previously uncharted object, not conforming to the gravitational norms we expect. Most unsettling of all, it was coming from beyond our solar system. Initially dismissed as just another space rock, the object quickly revealed patterns that defied explanation. It was moving too fast, its path too precise, and its reflected light far too bright. When astronomers backtracked its trajectory, what they found sent a chill through the scientific community. It was headed directly toward the center of our solar system. For decades, space was believed to be silent, still, and indifferent, but this object disrupted that belief. As it moved closer, the James Webb Space Telescope was directed to observe it. What began to emerge from those observations hinted at something far more complex than previously imagined. Some scientists began to ask a deeply unsettling question. What if this wasn't just a passing object? What if it was observing us? Between June 25th and June 29th, the object was officially logged by the ATLAS Asteroid Terrestrial Impact Last Alert System, a system specifically built to detect hazardous objects before they approach Earth. But this wasn't just another asteroid. The object, now designated 3I, pronounced 3I, displayed characteristics that made it stand out. It was traveling at speeds exceeding 152,000 miles per hour, far beyond the velocity of typical solar system bodies. Its path did not follow any known gravitational loops, neither like those of comets nor inner solar system wanderers. Simulations tracing its origin revealed it hadn't come from the Oort cloud or the edge of our system, but from deep interstellar space, possibly originating near the center of the galaxy. This wasn't some ancient relic of our solar system's formation. This was something that had been traveling through the dark for tens of thousands of years, unseen, and only now entering our cosmic neighborhood. The timing raised further questions. Before 2017, humanity had never detected an interstellar object. Now, within less than a decade, 3 such objects had appeared, and each one stranger than the last. After initial detection, observatories and scientists worldwide rushed to get observational time with the James Webb Space Telescope, the most advanced observatory ever built, capable of peering farther into space and time than anything before. But this time, the telescope's focus was on something much closer and far more enigmatic. The object's brightness did not match its size. If the reflection of light was accurate, the object should have been massive, but measurements indicated it was far smaller. This suggested the surface was highly reflective, more like metal than rock or ice, possibly even hollow. Harvard astrophysicist Avi Loeb, who had previously proposed that the 2017 object Oumuamua could have been artificial, once again stepped forward. He urged his colleagues to examine the object for signs of non-gravitational acceleration, small but measurable shifts in motion that couldn't be explained by the sun's gravity alone. If such anomalies existed, it could imply the object was not simply drifting, but maneuvering. And if that was the case, then it wasn't a rock at all. It was making decisions. To grasp the significance of 3I, we must revisit the 2 interstellar visitors that came before. In 2017, Oumuamua startled astronomers with its unusual elongated shape, lack of a comet tail, and unexplained acceleration after passing the sun, even though no gases or propulsion mechanisms were observed. Then in 2019, a second object, Borisov, appeared. It was a comet, but faster and more unstable than anything previously recorded. Each object left scientists with more questions than answers. But 3I was different. It seemed to combine the optical brightness of Oumuamua with the strange trajectory of Borisov. It didn't behave like a typical asteroid, yet didn't neatly fit into the category of a comet either. Now, scientists are considering an even more unsettling hypothesis. These might not be isolated incidents. They could be connected, forming A larger pattern is slow, intentional sequence disguised as random cosmic events. For centuries, the skies above were empty. Now, suddenly, they are not. And the only variable that has changed is us. Amid all the data trajectory simulations, light curves, spectrographic readings, one question quietly loomed. What if this object isn't natural? When brightness levels are too high, paths are too clean, and motion doesn't follow gravity, it leads to an uncomfortable possibility: artificial origin. Not necessarily alien in the way popular culture imagines, not flying saucers or humanoid beings, but perhaps autonomous probes, built by civilizations far more advanced than ours, sent long ago. Avi Loeb suggested that we might have already missed a signal from Oumuamua, and that 3I could be our second opportunity. Its reflective surface, its incredible speed, and the strange timing of its appearance all point toward intentionality, toward design. The James Webb Telescope continued to observe its spin, thermal emissions, and path. But the true answers might not lie in what the object is, but who or what might have sent it. In a galaxy that is 13.8 billion years old, the most chilling realization may not be that we are alone, but that we've always been watched, and only now have become capable of noticing. As more data flowed in from Webb and supporting ground-based telescopes, the object revealed even stranger behavior. It was accelerating, but not due to solar radiation. There was no gas or dust trail, no plume of particles, no cometary outgassing. And yet, the object was shifting course in a way that defied standard astrophysical models. Webb's infrared imaging revealed a stable, directed thermal signature, not chaotic like typical ice bodies, but patterned and controlled. This echoed the same phenomena seen in Oumuamua, where a similar unexplained acceleration sparked hushed concern among scientists. This time, however, the anomaly was not ignored. It was documented, monitored, and increasingly feared, because movement without an observable force implies control. With Webb's instruments trained on it, NASA's Goddard Space Flight Center conducted a full spectral analysis. Expectations were simple: the object should contain silicates, iron, or ice, normal elements found in space debris. But the results defied those expectations. The object's surface composition didn't align with any known asteroid or comet. Some of the absorption lines pointed to advanced carbon structures, compounds more typically associated with engineered materials than natural formations. It reflected light far too well. Even more bizarre, the way it rotated showed hints of symmetry, something extremely rare in natural cosmic objects. One side absorbed more heat than the other, suggesting a possible design choice. Electromagnetic readings even hinted at internal cavities or structural layers, indicating complexity. It didn't seem like a natural rock at all, and if it wasn't natural, what was it? This question began reverberating from NASA's Jet Propulsion Lab to European and Indian observatories, and even into classified defense channels, because if nature didn't create it, then something or someone did. As public curiosity grew, an unexpected silence began to fall. Agencies that had been releasing data trajectory updates abruptly went quiet. Web pages tracking the object stopped updating. Requests for telescope data were denied under internal review. Journalists who filed information requests received heavily redacted responses. Whispers began circulating. Research teams had been quietly reshuffled, access to live telescope feeds had been limited, and internal reports were no longer being shared. What had changed? Some in the astrophysical community began to suspect that a discovery had been made, something extraordinary, and that world governments were struggling not just to understand it, but to decide what the public should be told, because when a discovery crosses the boundary between science and existential significance, it enters a different realm, one not ruled by openness, but by control. In space, control isn't just about signals, it's about silence. The object, still silently gliding through our solar system, has become more than just an anomaly. It is a turning point, a moment forcing a reassessment of humanity's place in the cosmos. If it is artificial, then it originated from a civilization unimaginably older and more advanced, one capable of building something to endure countless millennia in the vacuum of space. One that perhaps never needed to speak because its mere presence was the message. And if it's natural, it represents a phenomenon so rare and sophisticated that it mimics design. Either conclusion is equally profound. The James Webb Telescope has effectively held up a mirror to our ignorance, forcing us to confront how little we know. We are no longer staring into an empty void. Perhaps the void has been staring back all along. As speculation mounted, a new, even more unsettling idea began to circulate, not through academic papers, but in private conversations and encrypted messages between scientists. What if this object wasn't just drifting by chance? What if its arrival, the development of our telescopes, and the increasing sophistication of our technology were all converging at a singular moment? What if this was a test and experiment designed to trigger a response, not just an artifact, but a probe, waiting to be detected by a civilization that had just become intelligent enough to notice it?